All right, so let's have a recap of our trig ratios, and all to do, of course, when you start off with our wonderful right-angled triangle, and the longest side is, of course, called the hypotenuse. And then when it comes to the other sides, it's in reference to a particular angle. So let's say it's that one. And then the one next to it, we call the adjacent. And the one across from it, we call opposite, of course. And from there, we get our ratios: sine, cosine, and tangent. And then we have the reciprocal ratios. All right. So you're getting a simple equation like this, and assuming we know we're talking about an acute angle. If it's not an acute angle, then the answer would be different. But assuming we're talking about an acute angle, the co means complementary. That's where the name comes from. So therefore, I know that the two angles should add up to be 90. So to work out x, well, 90 minus 25, 65 degrees. So if we get a question like this, cotan and tan, and we haven't got a definite angle there, but again, we can use that idea. We say, well, we know these are complementary angles. So x minus 20 plus x plus 30 is 90, and we get x equals 40. So when it comes to right-angled triangles, there are basically three types of questions. So this first one here, we have to find a side that is not the hypotenuse. So we set it up into the particular ratio we want. In this case, opposite over adjacent, so it's the tan ratio. So a over 13 is tan. So we end up multiplying by the denominator. A is 13 tan 61, and we get 23.5 units approximately. The next type is when it is the hypotenuse that we want to find. So this time when we set up the ratio, the unknown's on the bottom of the fraction. So to tidy this equation up, instead of multiplying by the trig, we end up dividing by the trig. So it's 5 divided by sine 32, approximately 9.4. And then the third type is where it's actually the angle that we want to find. So here we have the cosine ratio. So cosine theta is 10 on 14, which means theta is the inverse cos of 10 on 14. Now, on your calculator, that just means you have to hit shift or second function, depending on your calculator, before you hit the cos button. So inverse cos of 10 on 14, and we get 44 degrees, 25 minutes. The exact ratios. Where do they come from? Well, the first set comes from an equilateral triangle. All sides are equal to 2. It's equilateral, so all the angles are equal to 60, but we chop it in half. So now the base becomes 1, it becomes a 30-60 triangle, bit of Pythagoras, the other side's the square root of 3. So from there we can work out our exact ratios. So there's 30 degrees, sine, cosine, tan, and we can also read 60 degrees. And again, we notice the complementary ratios are the same. Sine 60, same as cos 30. Sine 30, same as cos 60. The other one, of course, is the 45-degree triangle. This one is straight away isosceles, so we'll make both sides equal to 1. Hypotenuse becomes the square root of 2. So for 45, once again, sine and cosine, well, in this case, they're equal, so we get 1 on root 2. So if you forget, the triangles are on the resource sheet that you get in the HSC, so you can always look them up anyway. I don't know whether you've seen this before, but there's a really neat way of these ratios. So you see this table, and you can say sine. If you actually look at it, it goes root 0 on 2, root 1 on 2, root 2 on 2, root 3 on 2, root 4 on 2. It actually works because 0 is 0, then you get 1 on 2, a half, that is sine of 30. Root 2 on 2 is 1 on root 2, which is 45, and then you've got root 3 on 2. Root 4 on 2 is, of course, 2 on 2, which is 1. Cosine's the same, but it reads backwards. And then to get tan, we remember tan is actually sine divided by cos. So it's the 2 above, but forget about the denominator. So I get 0 on root 4, root 1 on root 3, root 2 on root 2, and so on. So it's a different way, I guess, of displaying those exact ratios. Right, ways of measuring angles then. So we get our problems. Angles of elevation. So to elevate, we're at the horizontal and we rise, we elevate. So theta there is the angle of elevation of B from A. So it's always from the reference point, from where the angle is that we're talking about. We also have an angle of depression, depress, lower. So we get our horizontal, we lower it. So this would be the angle of depression of x from y. Now, of course, in a diagram, those two will always be equal. The angle of elevation is always equal to the angle of depression, because imagine we merge those two pictures together and we'd have alternate angles with parallel lines. Compass bearings. So the compass bearings was when we have the north, northeast, south and west. And then we divide them exactly up, so 45 degrees. And we always start with the north-south. So we go northeast, so north gets mentioned first. Southeast, south gets mentioned first. Southwest and northwest. We can keep doing that. To name them, you start with the higher level, if you like. So the top one, the higher level, would be north, and then we're going to the northeast, so it becomes north, northeast. The next one down, east is the highest level, but we're going towards the northeast, so it's east, northeast, and so on and so on. And theoretically, we could divide again. So if we were in between, which one shall we say? Say we're over here, halfway in between southeast and south-southeast. The higher level one would be southeast, so you would call it southeast, south-southeast, right? But that would be halfway between those two. But of course, that's when it starts getting a bit ridiculous. So we also have true bearings then, and that's the one where you just start at north. How many degrees have you gone in a clockwise direction? So here's x and y. Say I was measuring from x. So that's where I place the compass. And let's say that angle's 30 degrees. So if I start at north, go all the way around, that would be a bearing of 120 degrees. And you'll sometimes see a T after it to indicate this is a true bearing. The compass bearing for that then would be south 60 degrees east. Now if I was to go the other way, now let's put the compass at y, bit of geometry, we can work out that angle there, 60 degrees. And so 300 degrees we've gone from north, and we have north 60 degrees west. The other thing to mention about bearings, I guess, is 3 digits. They're always 3 digits. So if you had 20 degrees, you'd actually go 020 for a bearing. Okay, 6A, I should say 2 to 5, I'll just pick some. Because I think they're just the basic, do you know how to use your calculator? So, yeah, I do know how to do that.